which has a really thick cell, that might survive an awful lot more tumbling around, but these things...
This video demonstrates what it's like to run a 50-minute lab exercise that will be followed up a week later in a 50-minute group-based activity for the whole class. Some of the keys to success include designing a meaningful overarching purpose with each task contributing towards it, creating tasks that need discussion among peers and that apply recently learned concepts, enabling expert-novice interactions for all students, and balancing variety and complexity of tasks. The hands-on lab shown here focuses on handling and observing real samples and gathering data that will be analyzed and synthesized in subsequent work. Handouts were provided online several days earlier, but we still start the lab with a minimal introduction to outline the tasks, clarify time to spend on each task, and clarify homework necessary for the subsequent follow-up class.
You can see here on the second page, you have a whole bunch of questions. You've got images to draw as well.
After the introduction, students move freely from sample to sample at their own speed and in whatever order they like. We allow students to work solo, as pairs, or in groups. Some students prefer working alone. However, most prefer the benefits of working collaboratively. Providing a variety of task types is important. Our students handle samples, measure them, draw sketches, and discuss ideas based on challenging, provocative, or open-ended questions. Labs like these should be experiences rather than routine fact-gathering activities.
Yeah.
And let's say you had an organism in it, okay, and then it died, and then the shell was kind of rolling around in the surf, going back and forth.
Two teaching assistants and the instructor circulate to interact informally with as many groups and individuals as possible.
About here, see the shell is there and it's come away.
I see.
They guide thinking with questioning rather than simply telling answers.
Lab one.
What is it?
It's a bivalve.
That's
Why?
two thoracics.
Thoracic.
Students also appreciate anecdotes and analogies that illustrate expert thinking and the enthusiasm for the subject. Instructors find that setting up the exercises is challenging and may take 2 or 3 iterations.
Once it's been running for a couple of times, it's pretty similar. The initial heavy lift, of course, is developing it. And that was, it involved quite an awful lot of work. But once that work is done and you've ironed out the wrinkles after a few times you've given it, it pretty well looks after itself.
Why do you think this interactive approach to teaching is effective?
Well, it gives the students a chance to explore. It gives them a chance to use basic logic in a paleontological context. It gives them the opportunity to see that fossils are an opportunity for discovery as well. They, even given this, the brief introduction we've given them to paleontology and geology, can actually make some pretty interesting and profound deductions about the samples that they're looking at.
From a personal perspective, how does this teaching strategy compare to lecturing?
I love lecturing, but I really like this as well. This is my opportunity in a class with lots of students to actually get to know them. In a lecture with 250, 300 students, sometimes it can be a fairly impersonal experience. This is an opportunity to sit down, talk, chat, and really to get to know the class.
The teaching assistants find working these classes challenging owing to diversity of student backgrounds, but also rewarding.
Seeing them sort of be able to access the part of their brain that controls the common intuition.
I guess similar with Stored, you got to talk to the students, you got to know them maybe.
Actually incorporating examples and stopping and talking it through with the students.
It's those light bulb moments, isn't it?
Yeah,
You suddenly see
yeah.
it. Oh, I get it now.
Yeah, you know, like
Yeah.
we were talking over there about the shell and the way up and everything. When they finally get to comes to them, it's like, wait a minute, it's just gravity. You know, they're like, oh, you know, and it's
Yeah.
great, it's fun.
Students enjoy these experiences and they also recognize the benefits to their learning.
I think it's really helpful to have like hands-on experience with the fossils, because even if you like learn in lecture about them, it's kind of hard to picture them. But if you actually come to the lab and actually like interact with it, it's a lot more helpful and you remember it.
When you're in lecture, everything is, You know, we have these ideal situations that we're assuming, we have caveats, we have conventions that we use for the class. You're always modeling things and fitting it to what things should be. When you come into a lab, you realize that the real world isn't like that.
When we write exams, when we see some similar terms, we can kind of relate to what they look like, and that enhances our memory and understandings of what they are.
It's very important that if we're actually going to be applying the skills that we learn here, that we have some practical experience.
In a class 1 week later, a group-based exercise will make use of observations and the intervening homework to interpret a geological section and to date the rocks and unconformities. This group work is illustrated in the subsequent video.